Today we are going to discuss about a small topic in this chapter, haloalkenes and haloarenes. This chapter is very important and we are now studying a very important part of this chapter, nucleophilic substitution reactions. Nucleophilic substitution reactions. Before going to what is nucleophilic substitution reactions, we have to understand what a nucleophile is. So, what a nucleophile is? Nucleophile. What is philic means? Philic means loving. Nucleophilic means nucleus loving species. So, any species which can be called as a nucleophile only when they have very much electrons present in them. Okay, in order to love a nucleus or a positive charge, they should be negative in charge or electron rich species. So nucleophiles are electron rich species and will definitely attack nucleophiles or electrophiles. That means nucleophiles will always attack electrophiles. Okay, that's this thing you have to keep in mind. Okay. First, then nucleophilic substitution reactions. What this substitution means? Just giving an example, let go for it. Carbon having 4 valency, haloalkane. Okay, this is a haloalkane with a nucleophile OH minus. React to give carbon OH plus X. Can you see the difference between these two? Yes, in the first step, the first side, left side, you can see that a haloalkene plus a nucleophile coming, and the second, the product, you can see that the nucleophile is substituted in the place of the halogen in the reactant. So, nucleophilic substitution reactions are those reactions which are initiated by a nucleophile and already existing nucleophile is removed by a coming nucleophile. X minus or halogen is a nucleophile. Halogen also is a nucleophile. So it is replaced by OH minus in this reaction. So the name nucleophilic substitution reactions. Here we are studying two types of nucleophilic substitution reactions. They are SN1 reactions and SN2 reactions. Both are very simple and very easy. You just compare and study and you will cleanly score high marks in that topics. Okay, first we are going to deal with SN2 reaction and next with SN1 reaction. Okay, what does this SN2 reaction means? SN2 means a substitution nucleophilic bimolecular. Okay, SN2 substitution nucleophilic bimolecular. And what does SN1 means? A substitution nucleophilic unimolecular reaction. Okay, coming on to the substitution nucleophilic bimolecular reaction. In this reaction, why that bimolecular means? Okay, bimolecular means in this reaction when carbon in this reaction carbon is bonded to coming nucleophile and also the living nucleophile at the same time. So at the same time it is bonded to two molecules and also two reactant, both nucleophile and the reactant are present at the same time. Here the rate of the reaction is 2, means second order kinetics. Here in this reaction SN2 reaction, nucleophilic substitution reaction, the rate is depends on the concentration of the reactant. That means haloalkane and also the concentration of the nucleophile. Okay, so it is a single step reaction, reaction, and also we have to keep in mind that it follows second order kinetics. Okay, SN2 reaction. In SN, we have to go for an example. I will show you. But keep in mind that SN2 reactions are the reactions here. The rate depends on, here is this, SN, always study that the converse. SN2 is a single step process and SN1 takes place in 2 steps. Okay, SN 2, here the reaction takes place, or the rate is totally determined by the concentration of the haloalkanes we are taking, and also the nucleophile, since it's a single step, and also it follows second order kinetics. While in the case of SN1 reaction, the rate is determined only by the concentration of haloalkane, not on the concentration of nucleophile, but it is a two-step process and it follows first order kinetics. So let's move on to the examples of SN1 reactions. SN1 and SN2 reactions. Let's move on to SN1 and SN2 reactions examples. Okay, SN2 reaction. Taking an example of methyl halide. Methyl halide, just an example, carbon with hydrogen, 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 and here a halogen present, OH minus, and coming nucleophile. Okay. Here the reaction. Look at this reaction here. OH minus will not attack in this front way. It will attack in the back side. Okay, why that happens? Because X minus or halogen is a nucleophile. So when a nucleophile comes to another nucleophile, it will automatically repel. And it won't come from that side. So it will come from the back side and attack. Here there will be no such repulsion. So it will attack from the back side and resulting in the formation of a transition state. Here in SN2, a transition state is present. What a transition state means? A transition state is very unstable and is and cannot be isolated. Okay, transition state means why it is called unstable. In we all know that carbon has mainly 4 valences, but in case of transition state, this carbon is bonded the constituents, so it becomes carbon. It is very difficult for carbon to stay in that carbon will finally or very fastly decompose into its product. So in that state, unstable, very highly unstable transition state and cannot be isolated from the reaction. So in this reaction, we can say that carbon is bonded to oxygen. Okay, let me show that. Let me show you. This carbon is bonded to oxygen. Is this the correct position? No, it is not the correct position. This is the position where halogen present. Halogen is going to leave while OH is coming, but it didn't bond it. Its bond, it's completely, it didn't formed its complete bond. Okay, these hydrogen 3 are present. This state is called a transition state. Here it is called transition state. It's very, look at this position. A carbon is bonded to 5 constituents. So this transition state is highly unstable, cannot be isolated, fine, especially very form very fastly from the products. And this carbon, here hydrogen, here hydrogen, here hydrogen, and here OH. This is the final product. Okay, you can see that in this reaction, this configuration completely got inverted from this to this position. Means there is an inversion of configuration happens. So when a nucleophile enters into this constituent, this reactant, the H hydrogen bonds or automatically get away from that nucleophile. Okay, nucleophile is somewhat a bigger size compared to that hydrogen molecules. So it move away from that position and the configuration got completely inverted in the case of SN2 reaction. So another important point you have to keep in mind is that here inversion of configuration happens. Here inversion of configuration happens in SN2 reactions. Okay, hope this is clear to you. Next we are moving on to SN1 reaction. What does this SN1 reaction shows? Okay, Oh, before that, I have to have to tell you one thing, that in the case of SN2 reactions, there is an order of reactivity. Means we have already told that carbon having 3 hydrogen atoms have a very, just I'm showing, carbon with 3 halogen plus OH. Here, OH can easily attack through backside since these all 3 are hydrogen, very less reactive groups. Okay, but in case of primary groups where this hydrogen is replaced by CH3 group. Okay, is it? So one CH3 group, methyl group come to this position, and so it becomes somewhat difficult for this nucleophile to go into that position. When another is substituted, when it comes to secondary, this hydrogen is removed by CS and the CS3, it becomes more steric effect comes. And also to the next, when comes to tertiary, another methyl group comes. So it becomes very much difficult for this nucleophile to come to that position. So the order of reactivity is that methyl halides are first, then primary, then secondary, and then final tertiary. This is the order of reactivity for nucleophilic substitution reactions, SN2 reactions in the case. Okay. And finally, we are moving on to SN1 reactions. SN1 reactions happens. I already told that it happens in 2 steps. So SN1 reactions, first step is the slow. So SN1 reaction, I am taking a CH3 thrice Br. Okay. In this reaction, you can see that this why we are taking bromide. Okay, this we are taking a tertiary bromide. Why we are taking a tertiary bromide is that because in the first reaction, this CH3 thrice forms a carbocation and a Br minus, means it breaks down. That means firstly in this reaction, SN1 reactions, first step, in this first step, this living halogen groups leaves first. Okay, that's the first step. And only in the second step, that from to this carbocation, only that nucleophile get attached. Is it clear? So this is the slow step while it is a very fast step. Okay, okay, in this CH3, okay, CH3 thrice, a tertiary carbocation on second step on reacting with the nucleophile, resulting in the formation of. So what makes it clear that a nucleophilic substitution reaction, SN1 reaction, there are 2 steps. In the first step, the halogen completely goes out, resulting in the formation of carbocation. Why we are taking a tertiary halide means tertiary carbocations are very stable compared to that say primary and the secondary methyl everything. So that we are taking tertiary halide for conducting nucleophilic substitution SN1 reactions. Okay, so here the rate depends only on the concentration of this reactor we are taking. So here also the reactivity in the order tertiary, secondary, primary, and finally methyl. So that's all about nucleophilic substitution reaction, SN1 and SN2 reactions. Here we can see that in this reaction, I already told about that there is an inversion of configuration in SN2 reaction. But in case of SN1 reaction, we can see that in carbocation, this carbocation, this nucleophile can attack from both sides. It can attack from either from the front side or from the both side. The effects are same. So there is the possibility of two products. Okay, so there is a 50:50 mixture will be formed and resulting in the formation of a racemic mixture. So in SN1 reaction, a racemization of racemic mixture is formed, while in SN2 reactions, there's inversion of configuration happens. So that's simply all about the nucleophilic substitution reactions, SN1 reaction and SN2 reactions. Always study this when by comparing these two. Okay, SN2 reactions are second order kinetics, SN1 are first order kinetics. In SN2 reaction takes place in a single step, while SN1 reaction takes place in two steps. Okay, here the order of reactivity is methyl, primary, secondary, tertiary in SN2, while in SN1 it will be tertiary, secondary, primary, and methyl. And in SN2 reaction, there's inversion of configuration happens, while that in SN1 reaction, that is is the racemic mixture. Okay, happens. A racemic mixture is formed. Okay, that's all about nucleophilic substitution reaction. Hope this is very clear to you, super clear to you, and thank you.